this thing that a particle will be under stable equilibrium if the potential energy is going to be minimum. Suppose if I have this case, when an object is kept in a concave upward kind of surface, next case kept in a surface which is concave down, next placed on a flat surface. So first one is stable, next one is unstable, no? And this is our neutral equilibrium. So in case of stable equilibrium, if I displace the particle by small amount from the position of the equilibrium, you see, there will act a force which will bring it back to its original position. And once it comes back to the original position, it will be returning back with some speed. And here we are considering no frictional force or any sort of dissipative force. So it's going to rise up to the same height on the other side. And then again it will come back to its lowest most point or the point of equilibrium, and it will keep on oscillating like that. So for any particle to undergo oscillation, it must be under stable equilibrium. No? Correct? Then only there will act some force which will be returning it back to its original position. Then only it could move back and forth around some point which we call it as mean position. So the point about which it is going to do oscillation, is it not a point of least potential energy? And it is a point of stable equilibrium. Stable or unstable, but is it not a point of equilibrium? So as long as it is a point of equilibrium, what will be the net force acting on the particle? Net force will be zero. So first point is, for oscillation, to occur, particle or the object should be in stable equilibrium. And there's something we call it as mean position, the point around which it undergoes oscillation. So mean position is the point of stable equilibrium. Stable equilibrium means, first of all, it is a point of equilibrium, so net force must be zero. And along with that, the potential energy at that point must be minimum. No? Like the way here, what kind of potential energy we'll be dealing with will be gravitational potential energy. So as compared to the nearby points, which point has got least potential energy? The lowest one, no? Okay. Next point. All simple harmonic motion or all SHMs are oscillations, but all oscillations are not SHM. A certain special kind of oscillation, we call it as simple harmonic motion, that we are going to see today.
And then it as harmonic. My board knows wherever they speak to the impact to walk to the moon. That when it everything is in, that is what. I just had it as to my signal.
Okay, I can take a new page. Those who are online, I can take a new page. No, anyhow, I'm going to share all of it still. It might be better if you can copy during the class only. For any particle to undergo SHM, what is the condition is, the force must be proportional to minus of x, where x is the displacement from mean position. And minus sign indicates that this force acts opposite to the displacement given to him. Or in case if force is coming proportional to minus x, then the acceleration that it will have will be proportional to minus x. So we are talking about linear SHM first. Next we'll see what really is meant by something which we call it as angular SHM. Linear SHM means particle will be undergoing translational motion. So only one kind of energy it will have will be the translational kinetic energy. So if I'll take the case of a spring block system on a smooth horizontal surface, so and the motion of this block is going to happen along a horizontal line. So see, gravitational potential energy is not the thing which is doing the oscillation here, because that is not changing at all as it moves on this horizontal surface. So basically it is the spring force which is going to cause this particle to oscillate. And to locate where is going to be the mean position, it is the point where the net force must be 0. And to have net force 0, what must be that point then? The point when the extension of the spring is 0, no? Correct, no? In this case, the mean position will be where the extension of the spring is 0. Now suppose if I consider this mean position as our reference. Reference means this point I will consider as our x equals to 0. And what kind of motion I have? 1D motion. Since it is undergoing 1D motion, then plus and minus will be used for telling the direction. Correct. Next, suppose if I displace the block by an amount x in this direction. So at this new place, if I'll ask you what really is the force that will be acting on the particle, will be acting in this direction. And what will be the magnitude of the force will be kx if the spring constant is k. No? Now, you tell me, in direction in which I have given the displacement x, what really I am calling it as plus x. No? Correct. It means, in this case, which is the positive direction that I have taken for our sign convention? Rightward direction only. And with that sign convention, if I write the force acting on the particle, since it is 1D, so plus and minus will be told for telling the direction. So if I'll ask you which way the displacement vector is, it is in our plus direction. So if I'll ask you, tell me the displacement vector with direction using plus and minus. So displacement vector will be plus x. Correct. So the force vector must be minus kx. And the force I can write down as ma. That will be equal to minus of kx. So A will come equal to minus of k by m into x. So whatever this acceleration is, it is coming directly proportional to minus x. So it is going to be something which will be undergoing SHM. And what really the velocity, I must write it down in this case. I can write down velocity as dx by dt. So the acceleration can be written as d square x by dt square. So d square x by dt square is basically equal to minus of k by m into x. So we are seeing here a new kind of differential equation. You get that now? What really it is the meaning of differential equation? A equation containing differentiation. And if at all, if I give you that, okay, there's a function whose differentiation is this. Find me that function. So what really you do? You do integration. And what really integration is, it is nothing but the guesswork. We guess what was the function whose differentiation came out to be like this. Correct. Same way, solving differential equation is kind of guesswork only. What must be the solution of this differential equation? The one that will be satisfying this equation. Okay. So I can, and there's a name for this kind of differential equation. What really you see here, the pattern, the double differentiation of x is coming directly proportional to minus of x. So here x is the position of the particle, which is basically a function of time, no? And its double differentiation, you see, is coming proportional to minus of the function only. In such kind of differential equation has got one kind of solution. I am not telling that is the only solution, the one that we are going to see in this chapter. So about this thing. Next I'll talk about how to solve this differential equation. So what we have, double differentiation is coming directly proportional to negative of the original function. We'll sit there, it might be better now. And hold. I need some more near, some more now, but Base 5 syllabus so much lagging what to do. I have to take this class. You know, we're going to find down. Someone from stay out. I can take a new page. Here we go. The words if I give you, check out there's a function y, maybe I write down as x, which is a sine bt, where a and b are some constants. So what really dx by dt will be? So if I'll ask you find the differentiation of sine ax, it will be a cos ax. If I'll ask you find the differentiation of cos ax, what it will be? Minus of a times sin ax. So dx by dt will become ab cos bt. No? Again you differentiate it. Double differentiation of this thing will be ab being a constant will be kept as it is. Differentiation of cos bt with respect to t will be minus of b sin bt. So it's going to become minus of ab square sin bt. Then just I could write it down as b square into minus of b square into a sin bt also I could write down. And what really sin a sin bt is? It is our original function x. So what we get is b square x. So double differentiation is going to come minus of b square x. So what was the function here? A sin bt. So whatever is the coefficient of the t, that is coming as a squared up term in front of minus x. A sin bt double differentiation is coming as minus of b square x. Correct? Correct or not? Maybe I can take another example. Correct? So what is the differential equation that we have got here? D square x by dt square equals minus of k by m into x. So whatever you see coming in as coefficient of minus x, that is square of the coefficient of t. So what I'll do, I'll assume that okay, there's a term omega, I will call it as root over k by m. So omega square is going to be equal to k by m. So our d square x by dt square is going to become minus of omega square x. So the solution of this differential equation is x equals a sin omega t plus phi. And if you'll ask me, sir, how this one is the solution of the differential equation, you can't argue about that. You plug the solution in the equation, if it is satisfying it, it is this solution. No? So you can do that. We do the first differentiation. So if I will do dx by dt, what really it will become? A omega cos omega t plus phi. If you are unable to do the differentiation, you go home and check out how to do this kind of differential equations and how to do differentiation of this kind of simple functions. Double differentiation of x will become minus of a omega square sin omega t plus phi. And a sin omega t plus phi is our x only. So it's going to become minus of omega square x. So it is satisfying it. So this is going to be the solution of the given differential equation. So next I will talk about what is the meaning of the terms that come in place of in this solution of this differential equation. So copy this on everyone. So whenever I see double differentiation of any function coming proportional to negative of the original function, then the solution of such differential equation, one such solution of such differential equation is sinusoidal solution. Sinusoidal means it could be either sine or cos, no? Because sine and cos can be interchanged into each other. I can write sine 30 as cos in terms of cos also by writing it as cos 60. So we could write it down in sine or cos, both will do the job. Obtain there any confusion? Those who are online, any doubt, man? Those who are online, any doubt? Maitri, understood, no? Bharat?
Yes, sir.
Danish?
Sir, like, can you again say why you took like omega is equal to root of k by m?
Well, I'm assuming it as whatever this k by m is, no? That is square of the coefficient of the term d, correct? See that a sine bt I have. What really that comes in place of coefficient of minus x? You see b square.
Yes, sir.
So k by m, suppose if I'm calling it as omega square, then what will come in as coefficient of the t term, omega, no?
Yes, sir.
For convenience, I'm doing like that. It is correct or wrong, tell me.
Yeah, right, sir. It's correct, sir.
Okay.
And I don't like that.
Because it's a little bit mathematical. I hope all of you are able to follow. You can take a new page now. Okay. So displacement or position is given by a sine omega t plus phi. So a is called the amplitude. So tell me, whatever input I give to the function sine or cos, the maximum it can become is to become plus a. The minimum it can become is minus a. So what really amplitude is? The maximum or the magnitude of
You know, and no one I knew
maximum displacement from mean position. Omega is called as angular frequency.
so I'm gonna be doing it.
And phi is called phase constant,
Nobody knows. Can you wedding?
or also called as initial phase. Suppose if I use the word phase, it should not get confused by that. Phase means whatever is the net input given to our sine or cos function. So what really is the net input I am giving to our sine or cos function that we have got here is omega t plus phi, no? So that is called as phase. Suppose if I call omega t plus phi as phase at any time t, then what really is the meaning of initial phase? Initial phase means the phase that will be at t equals to 0. So what really initial phase means?
And I'm sweet to
The phase, whatever I have at t equals to 0, if I use t equals to 0 in that phase, we get it to be equal to phi. That's why it is also called as initial phase. And something we'll be discussing it in today's class only. To determine phase constant, what we are supposed to know is, so value of the phase constant depends upon
and feeling
the choice of t equals to 0. See, whatever the spring block system I have considered, we are not considering any kind of frictional force or dissipative forces. So it could be, theoretically I can say it will be oscillating. Right? It could be oscillating, can be oscillating till eternity. If there is no frictional force at all, it will be oscillating forever. So the value of the phase constant depends upon when I started observing the experiment. What is the choice of our t equals to 0 is? Suppose if at t equals to 0, if it was at x equals to 0 moving towards the one of the extreme position, which is x equals to plus s. It could be doing anything the time I started observing the experiment, no? We'll see this thing in more detail. So to decide the value of the phase constants, the thing that we need to know is displacement
Well, if you
and direction of velocity at t equals to 0. So depending upon where the particle was located at t equals to 0 and in what direction it was moving at t equals 0, that will be used to decide the phase constant. And the value of this phase constant must lie in between closed bracket 0, open bracket 2 pi. You get that meaning, no? It means it should be more than or equal to 0 but less than 2 pi. There's a reason for it. Suppose if I give you phase constant is 30. So using 30 is same as using 390 also. Using 720 plus 30 also. So there can be several infinite possibilities. That's why to have such kind of headache. Every value of the sign can be taken just by moving from 0 to 360. That's why we consider taking this phase constant to be something lying between 0 to 2 pi but less than 2 pi. Okay.
you're just going to get something out.
No, that's something that you might have done in chemistry. In your fella give you y equals sin x. What is the time period of the sine function is 2 pi? Pi, no? No? After how much time it will repeat itself? No, trigonometry done. Sine 2 pi plus x is how much? Sine x. Sine x. So it is repeating its value after an interval of 2 pi. So 2 pi is going to be the time period of sine x. Next, if I give you y equals sine 2x, its time period is going to be 2 pi by 2, which is pi.
Pi.
So if I give you a function y equals f of x, whose time period is, let's suppose t.
Not alone. Honestly,
And next I give you another function y equals f of a times x. Then the time period of this function will be t by a. Okay. T by a. So actually it is clear. Gokul, you have joined just now, man. I'm recording this thing also. You can check it. I'll save the recording.
Yes, sir.
If you want, just I'll repeat it a bit. She going to repeat.
that's right. But
Okay, still I'll try. Suppose if I have a spring block system, the point or the position where net force will be 0, we call it as mean position. And there the spring extension will be 0. And if I consider that point to be our reference, so we'll consider that is our x equals to 0. And rightward, I am taking as our positive direction. At any point of time, if my block is at position plus x, then what force will act on him will be kx, but opposite to the way that displacement is given to the block. So the force will be minus kx, ma will be minus of kx, a will be minus of k by m into x. And then what I do is I consider writing omega as k by m just for convenience. So omega square will be k by m. So double differentiation of x will be minus of omega square x. So it is a differential equation whose solution I am telling you is this. And why it is the solution? You can plug the value of the x in the equation, it will satisfy it. And there's a meaning to these terms that we get across. Coefficient of the sine function, or I could use cos also. The only difference will be in the phase constant. Suppose output of this thing at any moment is coming same as sine 30. So I could write it down as cos 60 also. But suppose if I'm using sine only, and whatever is multiplied with that sine or cos function will be called as amplitude. That is the maximum displacement the particle will be having from mean position. Coefficient of t we call it as angular frequency. Phi is called as phase constant, whose value depends upon at what time we started observing the experiment. So to decide what really will be the phase constant, the minimum thing I need to know is the displacement and the direction of the velocity, not the entire velocity. I just need to know what is the direction of the motion is. And what we have is 1D motion. So just we need to know whether the velocity is positive or negative. No? So we need to know the displacement and the direction of the velocity at t equals to 0. And phase constant is going to be lying between 0 to 2 pi, more than or equal to 0, but less than 2 pi, not equal to 2 pi. And if I have a function y equals sin x, its time period is 2 pi, means after 2 pi interval, it will be repeating its value in the same exact manner. Then time period of sin 2x will come 2 pi by 2. So if I have a function y equals f of x, whose time period is t, then for a function y equals f of ax, means like the way what is coming as coefficient of x is 2. So time period will be t by 8. Okay. I can take a new page.
Nancy,
So what really is the meaning of time period? First we will see.
and you will find one.
So this is the block which is undergoing oscillation. And suppose I started observing it when it was at x equals to 0, at t equals to 0, moving towards the position which is x equals plus n. So here lies our x equals plus n. So how much time this is going to take to reach this extreme position x equals to 8? I'll say it is going to be total time period by 4. Or whatever it can be. But what time it will take to return back to the same place again will be same only, no? But whenever it returns back to the same place after whatever time, what will be the position it will have? It will be at the same position, just it will be moving in opposite direction. So once it returns back to its original position, is it just enough to say from this is completion of one time period? Or is it correct to say it is the completion of one oscillation? No. It should return back to the mean position while doing things in the same exact manner. Then I'll say things are getting exactly repeated. Common system. So it will take t by 4 to reach the extreme x equals plus a. It will take t by 4 to return back to its mean position. Then again it will take t by 4 to move to the other extreme x equals minus a. Then it will take again t by 4 to return back to its original position while moving in the same exact manner. So what really time period is? The minimum time after which the particle returns back is going to return back to its starting point while traveling in the same exact manner.
Everyone,
So this is something in general. No, time period means minimum time after which position and velocity of the particle is same. And here we are conserving total mechanical energy because we are considering absence of any kind of frictional or dissipative force. So what really the equation of the displacement function or position function I have? It is a sine omega t plus phi. So what really will be the time period then? This is something how to find the time period. And what really is the time period, that is different thing, no? So if I give you a function y equals sine 2x, its time period is 2 pi by 2. If I give you y equals sine 3x, its time period will be 2 pi by 3. So what I have sine omega t. So what is the coefficient of the input variable t? It is omega. So the time period will be 2 pi by omega. And what really the omega we got here is, it is the omega square was the coefficient of minus x in the expression of acceleration, which is a equals minus of omega square. So whatever was the coefficient of minus x in the acceleration function, that is something which is our omega square. No? So first we will see how to find that phase constant. I can take a new page now. Everyone is comfortable with whatever I have told just now? All of you understood, no? Gokul, understood or not?
Yes, sir. Up to the yes, sir.
Cool. Copy this thing, I'll take it.
Sir, can you repeat time period alone, sir, once more?
The time period is the time after which particle will be returning back to its same position while traveling with same velocity. So suppose if I consider this particle starting from its mean position, which is our x equals to 0, then it will take some time to move to one of the extreme where the speed will become 0. Correct? Till when it will keep on moving? Till it has got some speed to move, no?
Yes, sir.
From that point, it will return back to its original position again. But at this time, whenever it comes back to the x equals to 0, it will be traveling in opposite direction. So that is not something we call it as one time period over. So it will go back to this extreme and then it will return back. Now once it is back now, it is going to be at same position while traveling in the same direction with same speed. Then so the minimum time after which the position and the velocity of the particle is same, we call it as time period. And time period can be asked to figure, you will be asked to find time period for any kind of motion. But for something which is an SHM, time period will be 2 pi by.
I've been thinking that.
Disconnect train call. Okay. I hope you understood now.
Yes, sir.
Why it is 2 pi omega? Because that is how maths works. No? If I give you one function, sin x, its time period, I am telling you it is 2 pi in case if you don't know. Y equals sine 2x will have time period. Whatever was the time period of the original function, dividing it with the coefficient of the x. So what x here is the input variable. So what is the input variable here I have is t. So what is the coefficient? T has got omega. So the time period will be 2 pi by omega. How to find time period? 2 pi by omega. What it is? Minimum time after which position and velocity is going to become same enough. Okay, then I'll take a new page. So first we'll see how to find phase constant. For that I'll take in one example. If I'll give you that displacement of a particle is given by a sine, it depends upon what really you're using, whether you're using sine function to represent the position or displacement or you're using cos function. Suppose if it is given that you use sine function and it is given that at t equals to 0, the particle is at x equals a by 2 and moving towards x equals plus a. So this statement given, moving towards x equals plus a, what really it is, the purpose is to know the direction of the velocity vector, no? So if this is our main position, x equals to 0, and at t equals to 0, we are told that particle is at x equals plus a by 2. So if right now the position of the particle is plus a by 2, so what really is the positive direction? Tell me this way now. Correct? Because what is the position I have given? Not minus, plus no? Means what really is the positive direction in our sign convention? Rightward. And at this moment it is told it is moving towards x equals plus a. So whatever velocity it is having, it is towards x equals plus a. So you tell me, what is the sign of the velocity vector? Positive or negative? Positive. Sign why we are talking about? Because we want to know direction and what kind of motion we have 1D. So plus and minus is going to be used for direction. So what really the information we have is at t equals to 0, the position of the particle is a by 2 and the velocity is positive. So the minimum requirement, or what all things you need to know to figure out the phase constant. To find phase constant you need position at t equals to 0 and the sign of velocity vector at t equals to 0. After that it is very simple. So what really is the position as a function of time? We have a sine omega t plus phi. So what we'll do, I'll use t equals to 0 in that function. What I get is a sine phi. And at t equals to 0, the position is a by 2. So a by 2 equals a sine phi. So what really sine phi will become? 1 by 2. So tell me what all possible values of phi can be. Keeping in mind that phase constant must lie between 0 and 2 pi. Can be equal to 0 but should be less than 2 pi. So 30 and 150. 30 and 150, correct? So two possibilities I have, 30 and 150. Then to decide or to exactly tell which one it will be, 30 or 150, I will find what will be the velocity of the particle. So displacement given by a sine omega t plus phi. I hope everyone can do this first differentiation. I mean, that x is given, maybe I'll tell you that even. Suppose if I give you x to be equal to a sine omega t plus phi. So what is the differentiation of this thing with respect to time will be? It will be dy by dt of a sine omega t plus phi. A being a constant will come outside. It will be differentiation of sine omega t plus phi. And differentiation of sine omega t plus phi, the coefficient of the input variable t will come in front. And differentiation of sine omega t plus phi will be cos omega t plus phi. No? So it will be a omega cos omega t plus phi. So now we know the velocity of the particle as a function of time, which is a omega cos omega t plus phi. And if I plug t equals to 0, what velocity will become? A omega cos phi. Now we will check. If I use phi equals 30 degrees, then what velocity will come? Positive, no? Correct? Cos 30 positive, no? If I use phi equals 150, what velocity will come? Negative. Negative means that is not correct or wrong, no? So which one will be our phase constant? 30 degrees. I hope you got the point. How to decide the phase constant? So first of all, you should decide which function you will use, sine or cos. If you are using cos, not wrong, but you will get different value of phase constant. I hope all of you understood now how to find phase constant. To find phase constant, you need to know at least two things. Position of the particle at t equals to 0 and the sign of the velocity vector at t equals to 0. Not the velocity vector I need to know in total, just its sign. No? Easy, all you know, and easy enough. Those who are online, easy, only know, and Gokul, easy or not?
Yes, sir.
So if you tell easy, when I feel like good that finding it easy. Doubt.
Yes.
Yeah, I don't
And that's me. Sunny.
To solve module, no?
So I gave it to Tulan. Anytime there. They are the outside of. And to hike pay will ask him.
Only hard work is not required, but smart work is also required. First solve the module, then you touch anything else. And seeing the kind of table JEE Mains is having now, our module is like overkill, man. Even just coming to the classes, listening everything and doing the questions that I did in the class, I think that can be also enough. But that you should not rely upon, because they can change the level next year also. Because of COVID and other things, maybe they are keeping it level to be a little bit less.
Sir, can you tell me why 150 degree is wrong again, sir?
If I use 150, what is the velocity will come? A omega cos 150, no? And cos 150 negative or positive? Negative.
Negative. Yes.
What is the velocity? In reality, it is positive.
Yes, sir.
So phi equals 150 is going to be wrong. Phi equals to 30 degree will be correct. And so,
Yes, sir.
so knowing the displacement, we can come to conclusion about two possible values of the phi. To further pinpoint which one is correct, I need to check whether 30 degree will give me the correct thing for the velocity or 150 degree will give me the correct thing for velocity. You should know. Cos function negative
Yes.
is second quadrant. Okay, I can take a new page. Copy this. Copy Gokul. After copying, tell me. I don't know whether you're copying at home or not. In class, you hardly copy anything properly.
Sir, completed. Over.
Okay, then next, first we'll see how to figure out angular frequency in time period in different cases. Fundamental method will be first decide what is going to be the mean position. And what really mean position will be where net force will be from 0. And even write down 4 equations. Draw FPD and write 4 equations at mean position. Next step will be displace the particle from mean position and then figure out net force acting on the particle in the direction of the displacement. What really I mean by this statement is, you consider taking the direction in which I have given the displacement as positive for writing the net force acting on the particle. Maybe I like that thing even. Consider the direction of displacement given from mean position has positive direction for the sign convention. You get that what I mean by sign convention? Using that direction as positive, you write the net force acting on the particle. And once you got the net force acting on the particle, step 3 will be the coefficient of the minus x in the expression of acceleration is going to be equal to omega square. Then time period will be 2 pi by omega. So this is what really will be the general method, and something which will be of use in any chapter, man, even in 12th also. If nothing works, you don't know what to do, this is what you will do every time. Then we'll come to several easy and shortcut ways as well, but this is the fundamental method. You decide which will be the point of mean position, that will be the point where net force will be 0, and draw the ABD and write the force equations, whatever necessary there. Then you displace the particle from the mean position, and after giving the displacement, you write the net force acting on the particle considering the direction of the displacement provided as positive. And once you got the net force, you can find the acceleration. And whatever will be the coefficient of the minus x in the expression of the acceleration, that will be our omega square. So once you get omega, t will be 2 pi by omega. The one thing that we have done already, that I will do it just for the sake of an example. So in this case, a spring block system is going to undergo oscillation. So in which direction it is undergoing SHM? Along horizontal. So when the net force along horizontal will be 0, when extension of the spring will be 0. So what I did there was, its spring extension I considered as our reference, or x equals to 0. And then I am going to provide this block a displacement from the mean position, suppose x. So whichever side I have given the displacement, no, that side I will consider as positive for the sign convention. And using this sign convention, I will write the net force acting on the particle. So what is the force that is going to act on the particle will be kx, which will be acting in leftward direction, which is our negative direction. So F will come minus of kx. So once I got F to be equal to minus of kx, A will be equal to minus of k by m into x. So whatever is the coefficient of minus x here is k by m, so omega square will be k by m. So if I got omega to be equal to root over k by m, the time period will come 2 pi root over m by k, no? Because time period will be 2 pi by omega. Okay. And you're supposed to remember this result as well. So first we decide which point will be the mean position where the net force will be 0. And the given system I have got block which is going to oscillate along horizontal direction. So when the net force will be 0 along horizontal, even spring force must be 0. That is going to be when extension 0. That I will take it as mean position. Then I have given a displacement x. And which side I have given? A rightward I have given. So rightward I will take positive. Force acts leftward. So F will be equal to minus kx. So it will be minus k by m into x. So omega square will be k by m. Okay, I can take a new page now. Copy this thing fast. This way you are able to understand, no man? Not a problem, no?
This way. I'm very true.
Okay. So if not copied, tell me, I'll return back to this page. Yes. Suppose if I'll give you a spring block system in vertical plane and spring constant given, and we have to find what will be the time period of the oscillation. So step 1 is we write down things at the mean position. At mean position, net force will be 0. So what I do, suppose I consider the extension of the spring to be equal to x0 at mean position. Then tell me, what all forces will act on the object at mean position? One will be mg and another will be kx0. And since it is under equilibrium, so kx0 will be equal to mg. So that is one equation we write. Next, step 2. So at mean position, the spring was already having an extension x0. Okay. Then what we are supposed to do is to provide a displacement to the block from the mean position. So this is the mean position. From there I am going to displace it to a new position down by x ups. If I do give the displacement, what will be the forces that will act on m? Mg still will act same. Now, if the block is pulled by x from mean position, what really will be the new extension of the spring will be? Already the spring was elongated by x. Already the spring was elongated by x0. And now I am further pulling it an extra amount by x. So net elongation it will have now will be x plus x0. So in this new position, the forces that will be acted upon him will be kx plus x0 upward, mg down. And in which direction I have given the displacement down? Correct now? So downward will be taken as positive for the sign convention. And using this sign convention, I will find the net force acting on the particle. Or we will find the force acting on the particle in the direction of the displacement. Both means the same thing only. So if I'll ask you what is the net force acting on the particle in down direction, mg acting down, so plus mg, no? Kx plus x0 acting upward, it will be minus of kx plus x0. So next we can simplify it further. Mg minus kx0 minus kx. Now from equation number 1, you see what we have is kx0 equals mg. So I can cancel mg with kx0. So what we got, net force to be equal to minus of kx. And then force I will write down as ma. So ma equals minus of kx. So what will be the acceleration we have is minus of k by m into x. So what is the omega square coming? K by m, same as the earlier one, no? So what time period will come? 2 pi by omega root, which is 2 pi root over m by k, same as the original one, no? And same as the earlier one. I hope you got it, no? And suppose if you forget the formula, you can't forget 2 pi was there because 2 pi by omega is the time period, and you can't forget root over was there. So what it can be, k by m or m by k, the one which will give me the unit of t. You can't forget it. No, spring constant is what? Newton per meter. So what will be giving me the unit of time, which is seconds? Root over m by k will give me that, not root over k by m. Correct? Suppose, or you can relate it like, or you can remember it like this also. More the mass, more will be the inertia. So more inertia means more time it will take to complete one oscillation. So M should be in numerator. Okay, also instruments. You take a new page. Says book. 10 or time almost 10 minutes to 10 minutes of random. My click capacity is very less, 2000 mAh left.
Very bit. The two hints to.
I said it. I'm an out and investing in the A's. The $4 yen banks getting was cheap.
There we go. Okay, that's. I think those are online. I can take a new page now.
Yes, sir.
Okay. I'll take one more example.
Randomly, nearly.
Suppose if I have a spring block set up lying on an inclined plane,
1 forward and 9 forward. 13, 10, 13 forward. And we go to London. Mustang down I'm made and forward. You really paid it.
and we want to figure out the time period of the oscillations it will do.
I'm aiming the road. Nothing to me.
So first step will be again same. Consider the things at the mean position where the net force will be 0. So if I consider that at mean position, the spring extension is x0, so kx0 will be acting up the inclined plane on the block. What else will act? mg sine theta will be acting down. Normal contact force getting balanced by mg cos theta. So mg sine theta is going to be equal to kx0. That is the equation number 1. Step 2, we provide a displacement towards the mean, away from the mean position. Whichever way you want, you can provide the displacement. Suppose if I displace the block from the mean position further by x down the inclined plane, suppose. So what will be the extension the spring will have now will be kx plus x0. mg sine theta is still acting same m down the inclined plane. And since I have given displacement in down the inclined plane direction, so down the inclined plane will be taken as positive for the sign convention. So in which direction you will find the net force acting on the particle? In down direction, no? So net force will be equal to mg sine theta minus of k x plus x0. Again, same thing like earlier or not. So mg sine theta minus of k x0 minus of kx. So again, mg sine theta I can cancel with kx0 using equation number 1. So what really we get? Same equation. F equals minus kx, ma equals minus kx, a equals minus of k by m into x. So what really will be our omega square k by m? Everything same enough. Time period will be 2 pi by omega. Copy this thing. I can take a new page. I can take a new. Suppose if I have a block which is floating in water while not fully submerged in the water, means the density of this block will be lesser than the density of the water, no? And suppose if I press that block into the water by a small amount, this block will undergo oscillation. So we will write down this is a block. This is a cubical block of mass m and area of the cross section is A. And let's suppose the total height it is having is H. And density of this block is given to us as rho naught. Density of the water is rho. Area of the cross section of this block is given as A. If the block is so we are going to push this block into the water by small amount and then we release it from rest obviously. So what will be the time period of the oscillations it is going to have? So first thing is we'll be finding out what really will be the things at the mean position. At mean position will be the point where net force will be 0. So step 1. Suppose at mean position, the buoyant force that is acting on the sky is suppose B naught. You can find that buoyant force even, but we don't need to. You'll see that B naught. Okay. So what will be the forces that will be applied on him? One will be the buoyant force upward. Another will be mg acting down. So B naught will be equal to mg. That will be our equation number 1. And now you can see what really the use of equation number 1 is to cancel something that will come in step 2. No? Next step, we are going to push that block into the water by an amount, suppose x. Suppose earlier it was x naught inside the water. Now I am going to push it into the water by some extra amount x. So the height of the cube that will be lying inside the water now will be x plus x naught. So further we are pushing into the water by x. Now what will be the buoyant force that is going to be acting on him now? So if I'll draw the earlier position when it was going to be, when it was inside the water up to x naught. The extra it is pushed into the water is by x. Is it not? So what is the extra volume of the water that is going to be displaced now will result into the extra buoyant force that will come into picture, correct? Correct or not? So the new buoyant force will be old buoyant force plus the extra weight of the water displaced, no? So what really will be the extra weight of the water displaced? Density of the water, area of the cross section into x into g, no? So this will be the new buoyant force. I hope you got this thing, no? So area of the cross section of this cube is A, and I am pushing it into water by an amount or length x. So this shaded region is the length x. So how much is the volume of the water that will be displaced will be A into x. No confusion about that one. Now I'll write down the net force acting on the particle in the direction of the displacement. So what all forces are on him are B upward and mg down. And we have given displacement x down. So in down direction I will find what will be the force in total acting on the particle. So net force acting on the particle now will be mg minus b, no? And mg minus b will be mg minus b naught plus rho a x into g. So mg minus b naught minus of rho A x into G. And I can cancel mg with B naught from equation number 1. So what force F will come? Minus of rho A x into G. And force F I can write down as ma. That will be minus of rho A G into x. So A will come out to be minus of rho A G by m into x. So what is the coefficient of minus x is? Rho A G by m. So our omega square is going to be rho A G by m. So what will be our omega? Root over rho A G by m. No?